to welcome everybody to the Iowa State Dairy Team Dairy webinar. Today's program is on weather and climate, and I think most of us have an interest in that. We're pleased to have Dr. Dennis Todey, Director of USDA Climate Hub in Ames, as our presenter. Dr. Todey's a native Iowan with his BS and Ph.D. from Iowa State. He worked 2 stints in South Dakota and then realized the error of his ways and is now back here in Iowa. We're delighted to have you present to us. And as I always say, the presentation, the podium is yours.
Okay, Fred, I didn't realize the error of my ways. I had to have something to move back to.
Okay, fair enough.
Thanks for having me. Appreciate being here today. Yes, as you may have heard, this time of year, winter meeting season time is a popular time for this. And I just realized that I forgot to change my intro slide here that I used from a talk I did yesterday in Cedar Falls. So I do apologize. But the information is updated as appropriate. So for those of you who've seen me before, I do like an informal presentation method. So, if you have any questions anywhere along the way, please do shout them out or put them in the chat. I'll try to monitor the chat as we go along here too, to deal with any of those questions as it happens. So, and Fred told me I had 3 hours, so I got 3 hours worth of material. No, we're not going to spend 3 hours here. We're going to hit right to the point. So let's go ahead and get rolling. Quick background of what we'll touch on today. Introduce a couple new tools that we've worked on with the Climate Hub and partners. We'll touch on some current conditions, obviously talk about drought, El Nino, how that's going to impact us. And then we'll touch on an outlook from that standpoint of what we can say for this growing season. Just a reminder of who we are. We are a part of USDA. We sit in the Agricultural Research Service. For those of you know campus at Iowa State, the national, used to be the Soil Tilth Lab, now the National Lab for Agriculture and the Environment, sits on the northeast side of campus, is where we sit. We officially cover an 8-state region in the Midwest, from Minnesota, Missouri, up to Michigan and Ohio. But because we are kind of the row crop experts also, we don't deal with a lot of row crop in other areas. We do expand out into the plains and Kansas a little bit to partner with them, and then a little bit in Kentucky. These are just the way we count our beans. We basically, anything related to agriculture, climate issues, from near term until future, is part of what we do as part of the Climate Hub. So we do a wide variety of crops. Obviously, I mentioned row crops, but we work on specialty crops, dairy, trying to do some more things with livestock. And I keep getting reminded by the folks down in Missouri that we have a decent amount of grasslands, at least in that part of our region, that we have to do some work with. So we do as broad a range of agriculture as we can with the staff that we have. Unfortunately, we've been able to add a few more staff. So I won't bore you with the whole organization chart of who we have, but we have several folks who have joined us over the last year and some more in the offing who can help work on a wide variety of issues. Okay. Quick transition to the tools I wanted to mention. This one is new that we have rolled out this fall. It is a climatology of soil temperatures, forage soil temperatures across our region. What we're trying to do is we have climatologies of temperature, precipitation, other atmospheric data that says, what are the averages, various averages over time, how they are changing over time. But there are some climatologies that relate to agriculture that we don't have as good information for, and we don't share those quite as well. So we talked with the Midwestern Regional Climate Center down here. out of Purdue University. They're a good partner of ours and said, I have this idea. So they came up with a data set that we could use across the region. And the goal of this is to try to understand when soil temperatures warm and cool and the dates when they hit some critical points in the spring and the fall. I'll go ahead and jump to the next slide here. So these are this showed the dates when we hit when they reach 50 degrees Fahrenheit in the fall, and then we've got the corresponding ones in the spring. We also have the freeze dates, and I think a couple other temperature cutoffs too, maybe 40 degrees Fahrenheit. So this is relatively new. We haven't done a lot with this yet. We are going to be having a webinar in the spring where we'll talk about this more. We're also taking input on this because there will be an updated version of this tool that we'll be able to share more information, maybe able to download some of the data, look at the changes over time, et cetera. So from an ag perspective, what we're looking at is especially critically those times when you reach 50 in the fall, when it's safer to do some nutrient application, or when we can expect some growth to start in the springtime when soil temperatures reach 50 in the springtime. So yeah, check that out. Here's the website down below. As per usual, all the things I show here are publicly available, so you can grab the websites here, or you can just send me a note afterwards, and I can share the slides with you. One other tool that I think I've mentioned before, briefly, a reminder of, is the last one was talking about soil temperatures. This next one we're talking about air temperatures. When we have our first freeze in the fall or last freeze in the spring, understanding how the dates of those are changing, because we can talk about overall changes in temperature and precipitation, but there are some critical, again, ag-related things of, when we have that killing freeze in the fall, or when we're safe from that killing freeze in the spring, and how those dates are changing over time. That's what this website does, or this tool does. So here we just show the trend in the first fall freeze dates on the upper left-hand side. This is the change in when we've hit 28 degrees for the first time. And basically, most of the central U.S. and northeastern U.S., the first time we hit 28 in the fall is getting later over time. And on the lower right-hand side is the spring one. So the first time we hit that, or the last time we hit freezing in the spring, is getting earlier. And if you combine those, then you can get an idea on how the growing season is changing over time. So these are all important agronomic related issues. And we're using freezing here, but we use a lot of other temperature cutoffs that may impact various crops vegetative issues. So check that out, have a look at that. If you have any questions about that, please shoot them out here and we'll address them. Otherwise, we'll kind of keep rolling with what's going on. All right, let's jump to some current issues here, looking at current conditions and kind of touching on what's happening regionally. Fred mentioned the cold. We have been quite cold here over the last week or so. It is interesting. I don't think I included that here, but depending on where you are over if we go back like the last 30, even the last 14 days, in some cases, we're not that much colder than average because we were so warm before we reached this time. So we'll talk about that more here in just a second. Let's focus on precipitation because we want to talk about drought. That's the big issues that we're looking at right now. Over the last 30 days, here's the precipitation on the left-hand side. The scale goes from anything that's in red or brown is lower, and then anything goes up to blues and purples is higher. Total precipitation on the left-hand side, percent of normal on the right-hand side. So the thing to focus on here is over much of the Dakotas, South Dakota, Minnesota, Iowa, parts of Nebraska and Kansas, we've been relatively wet with the rain we had around Christmas time and this includes the liquid from the last couple snowstorms. We've actually been relatively wet for this time of the year. But when you put that in context, that was the last 30 days. Here's the last 6 months. We haven't moved the needle on drought in some places because the total precipitation we received still doesn't match up with the deficits we're dealing with over a longer period of time. Here's the total precipitation on the left and percent of normal on the right here. So some places out in the plains were actually near to above average since the last 6 months. Centered over Iowa here, Northwest Iowa's actually had some rain in the fall, improved their soil moisture situation, but much of Iowa is still 70 to maybe 50% of average over the last 6 months. And that's quite dry. I'm not telling you something people don't know. It's been very dry overall. And then even some places in the eastern part of the Corn Belt. So this is a real issue of what we're dealing with and understanding why, despite having had, quite a bit above average for this time of year, we really haven't moved the needle overall on the drought perspective. And we'll talk more about drought as we go along. And that comes after December. This is a ranking map showing what December was like. On the left-hand side, Iowa was 129th of 129 years, warmest December on record, 129 years. But that despite not having much early month precipitation, that precipitation in the late part of December put us 110th, would be about the 19th, the 19th wettest December on record. So kind of an interesting combination there overall. What that does mean when you combine this on the way of soil moisture, we have these couple products. These are national products, so they're not actual measurements in the ground, but trying to assess where we are using various inputs, satellite information, precipitation, evapotranspiration. And basically the scales work the same. Anything that's yellow or brown is drier. Anything that's on the green or blue is wetter. And these are both on percentile scales. So basically, if you had 100 years of data, Northeast Iowa would be some of the driest we've had in 100 years worth of data based on this model. And the other model here on the lower right-hand side tells you the same thing. There's a little bit of variability, like in northern Illinois, as to whether we're still dry or getting closer to average. And then the Dakotas and parts of Minnesota have actually been somewhat wetter than average for soil moisture situation overall. Related to this, where are we in the way of soil temperatures? Left-hand side is a regional product showing soil temperatures. Any place that's in white, where forage soil temperatures are frozen. If it's not white, we're not frozen at this point. And on the right-hand side is where we are from, I guess this is a couple days ago now, for Iowa. The red numbers are the actual measured numbers. So 28 west central Iowa, 31 up at Sutherland, 28 at Kanawha, but the eastern part of the state still above freezing. Those warm temperatures we had before we got snow on the ground, kept those soils relatively warm. And now that we've got snow on that ground, it's not going to cool down very quickly because we've got a nice insulating layer over them. And that corresponds to what we're seeing in the way of frost depths too. Relatively shallow frost depths, 5 to 7 inches parts of Iowa, actually better than some places up in Wisconsin where there's no frost in the ground at this point. And then just to put this all in larger context before we dive into drought a little bit more, Iowa has been in some level of drought going back to June of 2020. So we're 3.5 years of having some level on the U.S. Drought Monitor. And over that time period, well, just in the last 3 years, here's the precipitation departures from average summed over the last 3 years. So all of Iowa is in the 20 inches or more of deficit over that time period. Some other places around us, not quite as bad, going down into Kansas, parts of Missouri are similar, a little bit in southeastern South Dakota, but Iowa is the epicenter of some of the driest conditions that we're seeing right now. So that brings us to discussion about drought, something that we've been hitting on a bit on this winter season, and something really important that we want to keep hammering on with people, not to reinforce and add to the stress, but to make people realize where we are and have people making wise decisions about where we are from a dryness standpoint. Here's the U.S. Drought Monitor from last week. I don't have this week's because it will not be released until tomorrow morning. The final touches are being put on that right now. The Drought Monitor is important because it does trigger some USDA programs based on level on the Drought Monitor and how long you're at that various levels. For that reason, we always want to make sure that this depicts as well as we can what's happening on the ground. and I'll share with you in a little bit where you can share information with us about how we correspond with the drought monitor, and information can be shared with us. So still much of Iowa in this D3 extreme drought. That's not the highest level, but it's the second from the highest level of drought. Nearly all of Iowa in some form of that. And then Missouri, Nebraska, Kansas, not as much to our north or not as much to our east also, though there has been some developing in the far eastern part of the Corn Belt over the last few weeks with some of the dryness that we've had. Here's a zoomed in map. So you can see a little better with the counties on it, where this lines up in Iowa and Missouri. So just a zoomed in look at that. We could go into look at it by state too, if you wanted to. Let's jump over this overall. Let's look at this one a little bit more, talking more about that drought issue specifically. This is a plot that shows precipitation for Iowa, for the state of Iowa, averaged over the whole state and then summed over the summer months, June, July, and August. And so each one of these dots is a year from 1895 until the present. And then the red line is kind of a running average. The blue line is a trend line over time. So a lot of variability, but you look at where we are right now over the last 4 to 5 years or so, and that compares with some of the driest periods we've seen. The summer precipitation would compare favorably with what we saw some years during the Dust Bowl. Not quite as bad as the Dust Bowl, but we're in that vicinity of discussion. So, and this comes in a period where we've seen overall more precipitation, a trend towards more precipitation over time. So it is an interesting context for what we've seen overall. If we look at annual precipitation, here's where we are with annual precipitation. The Dust Bowl is a bit worse. We would be comparable to some of the drought we saw in the 1950s in the way of annual precipitation. But to let you know that we are in a run of historically dry conditions compared to some of the worst that we have seen overall in the state. Okay, so just to connect you with what I mentioned about wanting for you people to be able to understand what's going on, share information about it. We have two ways, especially talking about drought, how to connect information about what's happening near you and sharing information that could be helped regionally. The first one is we always like to have impact reports of, hey, here's what's happening around me. Here's what's happening in the way of crops. Here's what's happening with water levels, whatever. You can always email me, or you can email Justin Glisson, the state climatologist, because we like to hear those, or you can share it via your local extension office, and they'll get them to us. If you want to do it more directly, there is something nationally called CMOR, Condition Monitoring Something Reports. I can't remember what the acronym is. You can take a picture of the QR code and go there directly, but you have an ability there to report, hey, here's what's going on around me. You can share pictures and put it in some context so that we can look at those reports and compare with what's on the drought monitor or what we're seeing and try to line those two up. Because we like to know, whether you get rainfall or don't get rainfall makes a big difference. And even sometimes when you get rainfall, if you're very dry in the longer term context, it's a real problem about trying to line up impacts with what's going on. The drought monitor won't always reflect yours specifically, what you think, but we try to align this as much as possible. The other way that you can contribute and share information with us is something called CocoRAS. CocoRAS is a national volunteer citizen science effort for people who measure precipitation. You get one of those, the 4-inch diameter, larger rain gauges. You set that out, you sign up on CocoRAS, do a little bit of training, and you can immediately start reporting precipitation. We like rain and snow. We can do snow with those too, if you're careful about how you do it, about how much rainfall or snowfall you had in your area. It helps us track how much water you did get, or when you don't get it, how much water you didn't get. So you get those local details that helps us assess things. And there's also a way of reporting your condition monitoring via CocoRAS too, if you're interested in doing that. Okay, let me pause here for a second. Does anyone have any questions or other things they'd like to know more about at this point?
If you have a question, you can just go ahead and unmute yourself and we'll take the question.
Okay, not hearing any. I'll go ahead and roll on here. We'll move on to the next topic, talking about El Nino. This is important with understanding what's going on currently and where we're going to be headed in the spring and the fall. Okay, just a reminder what we're talking about with El Nino. We're talking about changes in the sea surface temperatures, the ocean temperatures in the central and eastern Pacific Ocean. Here's South America over here. Here's Australia on the lower left-hand side. Here's Central America up here. And this large tongue of various colored water is showing how much, or showing areas that the sea surface temperatures are warmer than average and how warm they are compared. These are on degrees Celsius. So you multiply by about 2 to get degrees Fahrenheit, or specifically 1.8 to get degrees Fahrenheit. So that red area and darker brown area indicate much warmer than average sea surface temperatures in this region. Very indicative of an El Nino. Not a historically strong El Nino, but certainly on the very strong side. That has had to do certainly with partially why we've been warmer than average this winter. We've got climate change issues too that are also warming our winters, but El Nino is going to help warm our winter. Plus, it may have had a little bit to do with those storm systems. We don't connect El Nino with individual storm systems, but I'll show you a figure where we might tend to see a bit more precipitation during El Nino events. So El Nino, and this is part of a phase of when this area is warmer than, you see if temperatures are warmer, this is El Nino. When this area is colder, it's called La Nina, the opposite phase. And when they're transitioning between those two, we're called neutral. Those are the three phases that we deal with here. And just talking about those three phases, what's going to happen with those? This graphic on the right-hand side kind of explains where we're headed. Each of these sets of bars across the bottom are associated with a 3-month period. Like JFM is January, February, March. MAM is March, April, May. MJJ is May, June, July. And there's 3 bars over each one of those that show the probability of being in one of those 3 phases: El Nino, La Nina, or neutral. If you add the 3 bars together, you get 100% because you have to be in one of those phases. So that, the bars for all the way through January, February, March are pegged out at 100. So we're in El Nino, we're going to be in El Nino into the springtime. As we get into February, March, April, May, the chances of being in El Nino become less. It looks like El Nino is going to start to weaken. And if you go back here and watch this area along the coast of South America, you see that warm water starts to weaken. It's indicating some less warm water. That's probably the first stages of the El Nino starting to weaken. And that actually, by the time we get to April, May, June, July, neutral conditions are the more likely outcome. So what that means for us: there are certain conditions associated at different times of the year with each of these phases. The problem when we hit neutral conditions is that we don't have the assistance of saying what El Nino or La Nina could do. So our ability to say too much about what's going to happen this summer is limited because neutral conditions, there's a wider range of what can come out of it. So El Nino is likely to go away and not influence us by summer. And in fact, by July, August, September, and maybe the fall, you see that La Nina and neutral are equally likely. We might get a return to La Nina by the fall. We'll have to keep an eye on that as we go along, but that's a possibility. Okay, I mentioned when we're in one of these phases, there are certain things that we can say. El Nino and winter. Snowfall during El Nino winters in January through March. The areas in brown have lower chances for snowfall, whereas the areas in blue have above average chances for snowfall. And until these last systems, this was playing out pretty well and still is playing out in these northern areas where we still don't have, we have much less than average snow. That's not kind of played out in some of these southern areas at this fall, but this is January through March. So that's that 3-month period. The other part about some of the stronger El Ninos since 1950 are what happens in the way of precipitation. And if you look at each one of these El Nino events and you look at Iowa or the Midwest centered on Iowa, you see it nearly all of these there was a wetter than average signal over most of these. Only 57, 58 was a little bit drier. Otherwise, each one of these has a green, and the darker green, we were more above average. So we were not surprised that we finally got a flip around to start getting warmer than average. You also see that most of these show drier than average in around the Great Lakes and the eastern part of the Corn Belt, Ohio Valley. Not all of them, but there is a tendency for that to occur. So those are just the kind of things that we were looking at. Okay, that kind of gives you kind of the background of what we're taking into account with this. So let's go ahead and jump ahead to the outlooks here and talk about what we see coming up and what we can say about, say the spring and the summer related to this. Okay, the outlooks I'm going to show you are most of them come from a part of NOAA called the Climate Prediction Center. These outlooks, there is a 6 to 10 day and an 8 to 14 day that is updated daily. So each day there is a new one of these. They come out about 2 in the afternoon. So I'll show you those. There is a monthly outlook and then a longer range outlook that are updated. They're updated the third Thursday of the month. So we're kind of caught in limbo here in that the new ones of these come out tomorrow. I'm going to show you a link to where you can come listen to a webinar and get the most updated ones, since we don't have those available. But I can give you a few hints. Well, basically the hints are that what I talked to you about El Nino weakening in the spring and what it's going to mean for the summer, those probably won't change too much in the outlooks related to this. These are nearly all based on probabilities, likelihood of something happening, not this is going to happen or this is not going to happen. We rarely have something like that. Now, these are also general sector. They're just created. They are not for general purpose. They're not created for a specific sector. So I'll show you also a product that we create from the Midwest Climate Hub, where we do an ag look at these and what the impact of them could be on various parts of agriculture. So keep that in mind. We'll look at that as we go along. Okay, here is the next 7 days. Quantitative precipitation forecast. Basically, what are computer models saying how much precipitation could happen over the next 7 days? This area, you see parts of the eastern Corn Belt is blue, is up to maybe 1/2 to 3/4 of an inch of precipitation. More likely going to fall is rainfall, because if you watch the near-term forecasts, you've seen that we flip back to warmer conditions going into early next week. That will be somewhat limited by snow on the ground, but we are going to get into some warmer periods. And we actually have forecasts of rain in Iowa the middle of next week. So some of this could fall as rain overall. So good chunk of Iowa, maybe 1/10 to 1/4 of an inch, not a whole lot we'd see out of this. And then maybe a little bit of snowfall in the near term. So here's that 8 to 14 day outlook. And now we start the probabilities. The temperature is on the left-hand side and the precipitation is on the right-hand side. And the redder something is, the higher probability of being warmer than average. And on this side, and bluer would be cooler. Here, the greener something is, the better chance of being wetter. Browner is a better chance of being drier. So more of a likelihood through the end of January that we are warmer than average. We flip back again to warmer than average temperatures next week. We'll start working on some of that snowpack that we have around, and that will moderate the temperatures some, but it's still looking pretty strong that we go to warmer than average conditions and bring this cold to an end for a little while. And that more active period may keep moving along with us here overall, at least through the end of the month. Now, I would usually show you a monthly outlook, but again, we're more than halfway through a month, and that's going to be updated tomorrow, so I'm not going to show you that right now. And then here we have a 90-day outlook. A 90-day outlook, so this takes us January through March, and this northern area of the U.S. more likely to be warmer than average, very El Nino. And I'm quite confident that the outlooks tomorrow will look somewhat similar to this, hinting at warmer than average over the region. And then eastern Iowa east has a slightly better chance of being drier. Plains area has a slightly better chance of being wetter. These are not strong probabilities, but there are hints that way. Both these are very El Nino looking-ish patterns, and I expect the outlooks tomorrow to that will be February, March, April, will look very much something like this. Okay, the same outlooks now for March through May, so that's the spring. El Nino influence is going to weaken, so we have a hint towards the warm side overall in March through May, and a hint towards the wet side, but very, very weak on both of those. So no strong indications that we can see of what's going to happen in the spring. We don't have much to say about any kind of delayed spring or what's going to be happening overall. Now, to this end, without hints at seeing getting very active and very wet, we're still going to have dry soils that are going to continue with us into the spring. I don't foresee enough precipitation that it really impacts and improves our soil moisture situation a lot. Northwest Iowa is closer because, again, they'd had a little bit more precipitation, or it was mentioned about up in the Sioux Falls area and parts of South Dakota. Things could be a little bit wetter up there, but for most of the state of Iowa, we have very dry soils and a lot of capacity to be able to take up any additional precipitation at this point. Now, if any snowfall is probably not going to help soil moisture either. I didn't show you a snowfall map. Currently, over the eastern part of Iowa, we have 2 inches of liquid sitting on the ground from these last 2 snowfall events. A little bit of that will enter the soil, but much more of it is probably going to be running off. And right now, that's not a bad thing either, because we are so dry, we need water in any kind of form. Soil moisture, aquifers, runoff into surface waters. We need water in all those. Then we go through June through August. El Nino seems to be gone by this point. So again, not strong indications, a hint towards the warm side. More of what we're seeing in our summers right now. Both of these outlooks are basically trend outlooks. More of what we see in the summers is warmer evenings, not as much warm daytime high temperatures, but warmer evenings on a regular basis. And then hints towards the, slight hint towards wetter in the far eastern part of the state and eastern part of the Corn Belt, but not a strong indication in the way of precipitation. That again is a problem because we have these dry soils and the carryover drought issues. We don't see indications that this year is going to be another dry year like we've seen, but without indications that we're going to get above average precipitation, we're still going to carry some of these drought issues over into the season. Okay, kind of summary overall. For Iowa, drought continues into year 4. I mentioned there are some comparisons to what we've seen in the Dust Bowl. Conditions overall are not as bad as we've seen in the Dust Bowl because agriculture has been, it does use some better management practices, but we still have some very serious water, soil, moisture issues. El Nino is helping drive our winter, along with climate change, with the warmer winter overall. So looking ahead, El Nino is going to continue to be in play in the winter and into early spring, and then it weakens, and that's why our ability to say too much beyond that is a bit more difficult. El Nino summers do have a tendency to be a bit better seasons for us overall, but it doesn't look like El Nino is going to continue for us in the spring. We will continue some slow drought recovery, but I'm not seeing a big end or big improvements in drought in the offing. If I showed you some of the drought monitor changes over the last month or two, you'll see Missouri and parts of Kansas have had more rainfall, so they've improved the drought monitor there. Iowa really hasn't shown much improvement to the drought monitor, even with those recent precipitation events, because when you put that current precipitation in the context of the deficits, it really kind of pales. So any water is good right now, but we need larger amounts of water on a more regular basis to be able to feel comfortable about our drought recovery. Because of the dry soils, I don't foresee major spring planting issues with wetness. We can get slowdowns because of cooler temperatures, so it's happened to us once or twice recently. But unless things turn very wet very quickly, I don't foresee any wetness problems in the spring coming up. So, some things I've been sharing with people, consider yield goals if soil moisture is not is not very good in your situation, because soil moisture may be a limiting factor, and it's may not be of value to try to fertilize for high yield goals if if the water's not going to be available. Since we're talking with dairy folks, make sure you're checking your water source, whatever your water source is, and see how it's doing, if you can do that. We have aquifers in the state that are struggling a bit because of the inability to recharge them with the lack of rainfall we've had recently. Surface water has also been a problem going on. So it's better, again, we don't want to stress people, but we want to have people looking at what's going on and making choices when they have an ability to make some choices, or developing backup plans, instead of getting to a situation where we don't have water, or water limited, or water quality is a problem, whatever it is, and you get a chance to develop alternate plans if you can plan ahead. And also managing soils again. Any kind of tillage pass loses soil moisture right now, so be very careful on that end. Okay, let's jump through a couple of these overall. And I mentioned that webinar series that occurs the third Thursday of every month. We do it every month, third Thursday of every month, because that's when the new outlooks are released. We do a webinar at 1 p.m. Central Time that is usually presented by a state climatologist. Justin Glisson, our state climatologist, does one about one a year, and we share it around the region. You get an opportunity to listen, and we do something similar to what we've done here. There is an opportunity to ask questions if people want to, and then it is recorded and the slides are saved. So if one of people want to go back and listen to it later, they're able to do that. I'm usually on there to answer the ag questions. A colleague of mine from NOAA, Doug Cluck, is the MC of it. We've been doing this for about 12 years now, to great success, with lots of partners involved below. One other product I wanted to mention to you, something we're doing in the Midwest Climate Hub, is working state by state around our region to develop an ag climate assessment. Basically, it's what is happening currently, what is the ag in the state? How is it being impacted by climate currently? What do we expect to happen in the future because of that? We've rolled out Illinois, Wisconsin is rolled out, Minnesota is very close. I have the final draft with me right now. Iowa's is in draft form, and it should be within the next month or two. I think we'll have it out on the street for people who want that. Well, then we'll gradually be working our way around other states in the region if we had anybody in here from that. And then I mentioned, if people are interested and this is our website, and that ag focused climate outlook, that we do something with similar to what I do here, but this is a written format. We look at current conditions, we look at some of the impacts going on, we look at the outlooks and say, here's where things are, Iowa and in the region. Where do we expect to be going? What are some of the impacts we can expect of various parts of agriculture? So check it out. It's freely available. You just have to go to the website, which is on the Midwest Climate Hub website. And speaking of which, let me jump down through these. These are some of the other projects we're involved with right now. If you want to know about those, I'll be happy to talk about them. But here's that contact information for the Midwest Climate Hub. If you would like to be on our newsletter so that when the new Ag Outlook or any new products come out, we share them to our newsletter or our email list. So we would welcome you to join and be a part of that. We'll be happy to get you signed up. These are some of the members of our staff right now, which is, again, growing, and nice to have lots of younger folks available and sharing information with people. So with that, I will pause and see if there are any other questions. What are the questions you have at this point?
Dennis, I've got a question, and maybe you will cover it in the program, but we're seeing more of these big rains. We get this deluge hit, and I take it that's really not helping our drought situation when the soil's hard and dry and it runs off. Am I missing something on these?
No, you're dead on. And that's one of the things that I showed you, that change in precipitation over time for Iowa. Along with getting more overall precipitation, we're getting larger precipitation events. And generally, larger precipitation events aren't beneficial for a large number of reasons. I mean, one, you're right. You get a big rainfall, you get some runoff. It helps to fill surface waters, so there is some value there. But there's a couple other downsides. One, if you have rainfall like this on any kind of poorly managed soil, or even if it's big enough, even a well-managed soil, you lose a lot of soil in that prospect. Or even not a very large rainfall event that falls on frozen ground, we move a lot of soil there, which is, that is bad. That's very bad news for us and our long-range productivity and our ability to deal with climate, because especially when you're losing those surface soils, that has the higher organic matter, and that has our better soils at being able to hold water and make it be available for crops throughout the year. So that is not a good one overall. And that is also something that we talked about at a project meeting at a conference this last year, how you could have simultaneous increasing precipitation and more drought. If you have more precipitation, but you have more precipitation occurring in larger events, but then have longer times in between those events, you can have both bigger precipitation and more drought because you're having these dry periods in between. The other part I didn't talk about in detail is we're also having a problem with some less midsummer precipitation and seemingly more evapotranspiration or more crop water use. So getting less summer precipitation and then using more water at the same time, that dries your soils out even quicker. So it is a complex sort of thing, affects crops differently, also affects water supply differently, but a very definite issue. So good question, Fred.
Any other questions? Just unmute and go ahead. Otherwise, Dennis can go ahead and can continue.
I guess the other thing too is we're always looking for input from people on various, various tools or information that would help them in their decision making, whatever part of agriculture they're involved with. We tend to get locked in on row crops a little bit because there's so much of that we have to deal with, but other parts of what we're doing is also important, different types of agriculture, but need to know, what is not, what people need or what's not available for some of the people.
I was wondering too, if you could address the dirty 30s comparison that you referenced earlier, because yeah, we were in severe drought, but I had several of my farmers tell me that this was really, really, a pretty good year for them crop wise, unless you want to talk also genetics and how that plays into all this with the crops.
Sure. Well, that latter part is definitely it. We've changed crop varieties that are able to deal with drought much more than we used to. But we still need water. We still have to have water overall to be able for crops to grow. And, again, we're talking here about comparing where we are right now with where we were in the 30s. So precipitation totals are similar. Also, the changing in management. I don't know that Iowa itself was as bad in the way of blowing dust and those sorts of things as what we were getting from the plains, where we were getting, heavily managed soils in the plains that were during the dry periods, strong winds were picking them up and blowing across the other parts of the Midwest. I don't know how much was locally sourced as it was more from the plains. So, fortunately, our ag management practices are better. There's less tillage, but there's certainly more that we can do related to this. There was one other thing you mentioned I was going to talk about here. Oh, yes. Let me go down here real quickly. Here's another interesting thing that I found. I was talking about how well, here, let me go back one more and how precipitation is changing. This is what's called a climograph. Okay, it's a way of summarizing temperature and precipitation month by month over the year. So The months are on the bottom, January through December. The lines here are the average high temperature in red, average low temperature in blue, and then the average mean for each month plotted. And the scale is on the right-hand side. So coldest average in January, the average coldest time of the year is right about now. That's a positive aspect, is on average, we should start warming up after this point. And then the average warmest in July. But what I've pointed out here is the green bars are the average monthly precipitation. Wettest in the summer, driest in the winter. This is what I was talking about, that wetter than average in December or January, when we average a little over around an inch of water per month. That doesn't move the needle very much when you look at the longer term deficits. But what I wanted to point out, what we've seen in the summer here. This is data. This is not longer term data like I showed before. This is last 30 years. And when we compare to averages, we use 30-year averages that end at the end of each decade. So the current averages we're using are 91 to 2020. And something that showed up in the data that hadn't been there the previous 10 years, and this really kind of hit me between the eyes when I saw this. Here's Grundy Center, Iowa. So the peak average precipitation is still in June, but then we have a drop off in July and then some recovery in August, and then we start to fall off after that. Most of the stations in the state would used to peak in June and then gradually fall off throughout the year. So we've seen this over the last 15 years, particularly this dryness starting to set in midsummer. So for people growing corn particularly, that's a real problem, or any kind of other plant activity. This warmest time of the year, and we're seeing overall less precipitation, is a real serious problem. There's Grundy Center. I was in Waterloo, so shared this for Cedar Falls, so there's for Waterloo. The real place where this shows up most severely is in Northwest Iowa, and up in South Dakota, Southeast South Dakota is seeing something similar, where the peak again is in June, but then a pretty big drop off in July before recovery in August. And that has me very concerned going ahead as to what we're going to be looking at in the future as we go along here. And then one other thing I took note of is I was trying to look at how much recent drought has impacted our yield productivity. I was just looking at corn, and I stole this graphic from the ISU Econ extension website. This is the last 10 years for what's happening in the way of corn yield. And there's a little bit of increase over that 10-year period, but especially since 2016 till the present, we're essentially flat. We've gone flat in the way of yields, and soybean yields are something similar to this too. So that even though we are getting improvements, and for what we've seen in the way of drought, people have been relatively pleased with what they have seen. Overall, this is NASS data. We're not seeing increases in yields around the region according to this. So this is an interesting thing that we need to dig in a little bit more. How much of this is climate related? There's obviously a chunk of this that is related to drought, but are there other things that are coming into play overall too? So, Deb, that take care of it for you? Is there anything else you want to follow up with?
No, that you answered it very well. Thank you.
Okay. Are there any other questions people have? Other things they'd like to know about, whether climate ag related or just meteorologically related?
I had one question come in asking, you had just kind of mentioned briefly about well water with the aquifers, and you mentioned quality. What kind of quality issues are you seeing or do you expect with the fourth year of the drought?
That's a really good question on the quality side. I know that, like when I was up in the plains, and you had livestock that were reliant on surface water, when you had dry conditions, you get worsening water quality. I don't know. Certainly, if you have livestock that are using a surface water, and that's becoming limited, there could be some increased water quality issues. I'll say general. I'm not a water quality expert. And then from an aquifer standpoint, I don't know if it would change quality issues or just become a quantity issue. We know that in Northwest Iowa, that's one of our problem areas because as long as it keeps raining relatively well, aquifers are okay. But we have lots of demand in that area, and if an extended dry periods, it becomes a problem for us. And I don't know the aquifers around the state very well to be able to point out ones that are problems, but I know the DNR has been tracking. And actually I would suggest they would be your contact point with the Iowa DNR, asking them for some of those questions to give some of that information.
I have another question. And we've always heard in general that what happens in California and on the West Coast eventually reaches us. So since we've been dry here in this region for a while, does that mean it's going to continue moving east?
Is the dryness from here going to continue moving east? Is that what you're asking?
Will it be moving east?
Okay. And I guess I answer those a little bit. I don't talk about dry areas moving, because when we talk about drought and wetness, we're talking about simply at a location, did you start getting rainfall or did you stop getting rainfall? And that's when we talk about rains or drought. So Iowa is the focus on this. Iowa is the focus because we've been missing out on some of these. Areas around us have had varying levels of dryness that have kind of morphed in and out over time. But I don't foresee other areas being quite as bad. That leads me to I can talk about one other graphic that I included here. Talking about drought areas in, we'll call it the Corn Belt. The drought monitor here, I've shown you, has been around since 2000. And you can zoom in on the map, or you can also look at time series and how much a percent of an area has been covered by drought. So like on the bottom here, this is how much the percentage of coverage of drought in Iowa since the beginning of the drought monitor. So 2000 here up until the present. And then the various coverage of the various levels of drought. So some around 2000, 2002, 4, 2006, 2012 carried into 2013, and then this extended period we've had since the middle part of 2020. So, there's varying levels of varying coverage over time based on who's getting rainfall and who's not getting rainfall. But then the other point that I'm morphing off on this question too is that drought years in the Corn Belt. Are we going to have a drought year in the Corn Belt? But these are the north central states, basically the states that comprise the Corn Belt, and here's the percent drought coverage of those areas. And you can pick about any year and say there was drought in the Corn Belt about any year. There are a few years, if you look through here, that there's less coverage. Like 2019 was that very wet year. We look back longingly at that time period that was wet. Some around 2010 that was fairly low, and around 2002 that we had some 2001 where we had some lower coverage. But otherwise, we have drought in the Corn Belt about every year. It's just some years there's more coverage, and who gets it? So I'm not expecting it to move. I'm expecting, various parts of the Midwest are going to improve as we get some rainfalls. Hopefully Iowa will, but there's going to be drought that's going to continue in the Corn Belt going on into the summer just because of the deficits that we're dealing with. Okay, is there anything else that's on your mind?
Do you have additional material you want to cover?
I can touch on a couple last things here real quickly.
Okay.
Part of what we've been doing in the Midwest Climate Hub, and we've been fortunate to get some additional funding. Part of this has been other USDA funding that has come through other universities to partner with them, and doing some work in the Midwest. First one is called Climate Ready Midwest through Ohio State, which is working with extension in various states and understanding, ability to program about climate and climate smart agriculture issues. And so we've been, Iowa was not officially part of this one. This was more Eastern Corn Belt with the states that were involved. Yeah, here's the states below: Ohio State, Purdue, Wisconsin, and then Michigan State, and also Central State, a historically black college, which was part of this. That one's a little over a year in. We're working on another one with Purdue called also on climate smart agriculture, where we're trying to understand practices and cropping systems and pulling together more information about those systems and understanding more about climate smart ag issues related to them. You hear this topic of climate smart ag with the change in administration. We've been, there's a lot more issue with climate mitigation related issues and climate smart ag also. Which if you want to know more about these, be happy to talk about them sometime. And then something that you might be interested in, we're a little bit late this year, but we're going to be starting another cohort later for producers and advisors to work together on the, called the Climate Adaptation and Mitigation Learning. They're called Climate Adaptation Fellows. It's actually being led by the University of Maine because they piloted this in the Northeast. And we have a couple of these working. You have a cohort of about 20 pairs of people, a producer and an advisor working together. We get some education. They do some project work together on outreach that is going to be coming out. I think we have one couple in Iowa of one pair and several in Wisconsin actually as part of this. So more to be coming about these. So I think that uses up about all my time, Fred. So I appreciate if there's any last questions, I will be happy to answer them. Otherwise, we can wrap it up.
Very good. If there are questions, now's the time. Go ahead and unmute or type them into the chat box. We'll give you just a few seconds to get that done. Not seeing any. Thank you, Dr. Todey. We appreciate the information. You gave us a full dose, and we appreciate that. Your contact information's on that last slide. I know you always encourage people who have questions to not be bashful, and I would reiterate that it seems like you're always ready to respond to a question. So again, thank you very much for presenting, and we'll look forward to having everybody back at next month's webinar. Thank you.